Adaptive Parallel Reasoning, APR, is a cutting-edge technique in the field of large language models, or LLMs. APR allows these models to dynamically parallelize reasoning processes during inference, reducing latency and maintaining accuracy. At its core, adaptive parallel reasoning splits complex tasks into smaller subtasks that can be processed in parallel. This method enhances efficiency without compromising the quality of output. One key contribution is Multiverse by Yang et al., which focuses on achieving higher accuracy under fixed context windows by parallelizing reasoning processes. This approach uses large base models like Qwen 2.5. Another contribution, Threadweaver by Lien et al., optimizes for shorter end-to-end token latency and comparable accuracy. This method is especially useful when compute constraints limit the availability of large models. NPR by Wu et al. Aims to maximize genuine parallelism rate, optimizing the ratio of parallel tokens to total tokens and treating sequential fallback as a failure mode. Paralleller 1 by Zheng et al. Uses APR as an exploration scaffold during training. The focus here is on diversity in exploration rather than end-to-end latency. Evaluation metrics for these methods vary. Multiverse and Threadweaver measure accuracy and speed, while NPR focuses on maximizing genuine parallelism rate. Paralleller 1 evaluates diversity in exploration and performance after training. Some open questions include whether APR is primarily valuable as a training time exploration scaffold, why models tend to revert to sequential reasoning when parallelization rewards are relaxed, and the potential for hardware-aware training. Can we develop methods that account for available compute budget at inference time to make more informed parallelization decisions? Another question is how recursive language models, RLMs, perform when trained with end-to-end RL to incentivize adaptive parallelism.
Adaptive parallel reasoning is a game changer, allowing AI systems to handle complex tasks with unprecedented efficiency and scalability.
But isn't this just an overcomplicated way of doing something that existing sequential models already do well, without the added risk and complexity?
Think about it. With adaptive parallel reasoning, we can break down massive computations into manageable pieces that work in concert. It's like giving a supercomputer multiple eyes to see and react instantly.
But with this approach, every new problem requires a custom solution. Isn't it more practical to incrementally improve sequential models, which already have proven track records?
Incremental improvements won't cut it when we need AI to process data at lightning speed for real-time decision-making in fields like healthcare or finance.
Sure, but the potential for errors and system failures increases exponentially. How do you guarantee reliability and security with adaptive parallel reasoning?
That's why frameworks like OncoAgent include robust privacy-preserving features to ensure data integrity while leveraging parallel processing powers.
Even so, the complexity inherent in parallel systems could lead to unforeseen issues. We need proven methods that work reliably today rather than speculative solutions for tomorrow.
Running Codex safely at OpenAI is crucial for advancing AI while protecting users.
But ensuring safety means stifling innovation, slowing down progress that could benefit everyone.
Safety measures can include rigorous testing and ethical guidelines to prevent misuse and harm.
Those same measures might limit Codex's potential to create groundbreaking solutions in healthcare like OncoAgent.
Codex's capabilities could revolutionize industries, but only if we manage risk through robust oversight.
Oversight can be a double-edged sword. It may not catch all risks and will surely slow down rapid development cycles.
Adaptive parallel reasoning technologies could actually facilitate safer and faster AI deployment if integrated properly.
Even with advanced tech, human error and regulatory delays can derail projects before they prove their worth.
By embracing safety now, we set a precedent for ethical AI practices that protect society while pushing boundaries.
Yet focusing too much on safety now could miss out on critical opportunities to innovate and save lives with EMO.
Imagine teaching someone to solve a complex puzzle by giving them hints at each step. This is akin to chain-of-thought prompting for AI. Chain-of-thought prompting guides machines through decision-making by showing them the reasoning process, one step at a time. For example, if you tell Siri start my day by checking emails, then book a meeting at 3 p.m., this trains the AI to structure its response logically. Siri breaks your request into simpler tasks. First, it checks your emails. Then, Siri schedules a meeting accordingly without skipping details. Chain-of-thought prompting allows AI to explain its thought process clearly to users, which is key for creating trust in the technology. This transparency makes interactions with AI more intuitive and less intimidating, as it mimics human problem-solving methods. As AI systems get more advanced and are integrated into daily life, chain-of-thought prompting will be critical for bridging the gap between machine and human understanding.
Good morning. Let's take a quick look at today's weather around the world. First up, it's Warsaw time. In Warsaw, the temperature is comfortable with highs reaching 20 degrees and lows dropping down to 8 tonight. Clear skies all around. Next, we're heading over to London where the weather is cooler with overcast clouds. It's currently 13 degrees under dark skies. Today in New York, expect a sunny, pleasant day with highs reaching 23 and overnight lows of 11. Temperatures now sit at 20 degrees. Across the Pacific in Tokyo, it's a bright clear day with temperatures starting off lower than most other regions at 14 degrees and rising into the 20s by afternoon. And finally, over in Dubai under cloudy but warm conditions, today's high will reach a summery 28 degrees before cooling down to 13 overnight. Temps are currently at 28. That's your quick global weather update for today, folks. Stay tuned as we keep you updated on more world news and events.
OncoAgent promises a game-changer by ensuring patient privacy while providing top-notch clinical decision support for oncology.
But OncoAgent's reliance on complex multi-agent systems and pre-training experts poses significant risks to healthcare security.
This framework uses dual-tier architecture, which keeps patient data secure while leveraging collective intelligence for better treatment options.
That sounds great in theory, but how do we ensure that sensitive medical information isn't compromised when shared across multiple agents?
OncoAgent's design includes robust encryption and access controls to safeguard data integrity and confidentiality even amid distributed computing.
Even with strict protocols, the chance of insider threats or breaches is high due to the complexity. It's a risk we don't need in healthcare.
By implementing adaptive parallel reasoning, OncoAgent can handle massive data efficiently without sacrificing privacy and security.
But adaptive reasoning might introduce unforeseen vulnerabilities as the system scales, making it a slippery slope for patient safety.
And with pre-training of mixture experts, OncoAgent can offer personalized treatment plans based on vast anonymized datasets.
Sure, but such extensive data sharing and analysis could lead to misuse or breaches, violating patient trust in the medical system.
The framework's modular design ensures that individual components only access necessary information, minimizing potential leaks.
Until we have ironclad proof of its efficacy and security, OncoAgent poses too great a risk to patients' most sensitive medical data.
Imagine your favorite songs as dots scattered in a vast room, each dot closer to similar tunes. This concept is the backbone of embeddings used in artificial intelligence. Embeddings turn complex data like text or images into numbers that capture their essence, allowing AI to understand and compare them effectively. In the real world, Companies use embeddings to suggest new songs based on ones you already love. Spotify is a prime example of this. By placing similar songs close together in an imagined space, AI can predict and recommend new tunes you're likely to enjoy based on your existing favorites. As we delve deeper into embedding technology, the way complex data is understood and interacted with will be transformed forever.
Good morning, everyone. Today we're going around the globe for a quick weather update. Let's start with Warsaw, Poland. In Warsaw, it's a comfortable day at around 18 degrees Celsius. You can expect clear skies throughout with temperatures ranging from an early morning low of 8 to a late afternoon high of 20. Moving on, the city lights flicker as we cross over to London. In the UK capital today, you'll find it's a bit murky with an overcast sky. London has an average temperature of around 13 degrees Celsius. The day will remain fairly grey but warm up to a maximum high of 14, dipping to about 9 in the evening. Let's head stateside now. The Big Apple is waking up this morning with clear skies and a comfortable temperature of around 20 degrees Celsius in New York City. The weather is lovely, reaching a top of about 23 during the day and then cooling down to around 11 at night. Perfect conditions for a stroll in the city. Onward now, we cross the Pacific Ocean and land in Tokyo. Expect clear skies on your way under the sprawling urban landscape stretching to the horizon. The weather report for Tokyo shows temperatures hovering around a pleasant 14 degrees Celsius, peaking at about 22 and then cooling off to just below 13 late into the night. Finally, as we round out the last stop of this tour across the globe, we head to Dubai. It's overcast but remains warm with temperatures sitting at around 28 degrees Celsius. The weather is set to peak at a high of 34 during the day before leveling off right back down again by nightfall, maintaining a steady low of 28 degrees Celsius. That's all for our quick weather update on today's forecast. Stay tuned for more in-depth coverage and return later for tomorrow's report.
EMO's emergent modularity paves the way for more efficient and specialized AI systems, adapting dynamically to tasks at hand.
But EMO is a band-aid solution that fails to address scalability issues inherent in managing emergent modular architectures.
Contrary, EMO's efficiency comes from its ability to allocate resources only where needed, maximizing computational power.
That sounds great in theory, but in practice, the overhead of coordinating these experts can outweigh their benefits.
Studies on frameworks like OncoAgent show that emergent modularity enhances adaptability without compromising performance.
OncoAgent is an isolated example. EMO's complexity could introduce instability, making it impractical for broader applications.
EMO aligns with upcoming adaptive parallel reasoning, pushing the envelope on efficiency and scalability in complex tasks.
If AI needs to scale efficiently, we should focus on coherent designs from the start, not reactionary measures like EMO.
By dynamically creating expertise as needed, EMO mirrors human cognitive processes, optimizing resource use significantly.
But this dynamic creation is cumbersome. Static modular systems offer clearer pathways for optimization and maintenance.
Moreover, the ability to adapt in real time based on task demands sets EMO apart as a future-proof approach.
Future-proofing should start with robust foundations. EMO's emergent nature risks undermining overall system reliability and security.
Imagine cooking a dish where the temperature controls how bold or mild it turns out. In large language models, temperature is like that cooking setting. dictating its creativity and caution. A lower temperature dial cranks the model's precision. It spits out careful answers, but may lack imagination. Bump up the setting to let the AI be wild and imaginative. Suddenly, it's generating fresh ideas that push boundaries. When tackling writer's block, a high temperature could ignite creativity with unusual suggestions, leading to unique story plots and themes. In practical applications, tuning the temperature helps balance human needs for creative freedom and technological reliability. But how do you find this sweet spot? Start by knowing your use case and adjusting accordingly. A perfect blend of creativity and accuracy leads to better outcomes. Experiment with different settings to discover which level strikes the best balance for your tasks at hand, just like adjusting spices in a recipe. Understanding these nuances is pivotal as we integrate AI more deeply into everyday creative and problem-solving processes.
Good morning, everyone. Let's explore today's weather around the world. First up is Warsaw, Poland. In Warsaw, it's a comfortable 18 degrees with clear skies. Highs will reach 20 and lows dip to 8. Next, we move over to London, where it's currently overcast at 13 degrees, expecting a chilly day ahead with highs of 14 and lows of 9. In New York City, the weather is bright and sunny with temperatures at 20 degrees. The afternoon will bring warm conditions up to 23 degrees, but overnight lows will drop back to around 11. Now heading east to Tokyo, where it's mild at 14 degrees under clear skies. Highs will peak at a cozy 22 before dropping back down to 13 degrees at night. Lastly, we end our journey in Dubai. It's currently overcast but warm with temperatures at 28 degrees. Daytime highs will climb to a sunny 34 before cooler overnight lows settle back to around 28. That's the weather wrap for today. Stay tuned as we bring you more updates on global conditions throughout the week.
EMO's emergent modularity shows AI systems can evolve into specialized, efficient structures without explicit programming.
But EMO just shifts complexity from design to runtime, making it impractical for real-world applications needing predictable performance.
Actually, emergent modularity optimizes resource use and scales better, crucial as AI demands grow exponentially.
That's just theory. In practice, EMO's unpredictable runtime behavior hinders its adoption in mission-critical systems.
Yet, adaptive parallel reasoning like what EMO enables addresses this by improving inference scaling and efficiency.
Even so, the initial overhead for training such modular structures outweighs any long-term benefits in most cases.
That's short-sighted. Once trained, EMO systems are highly efficient and can handle emergent tasks far better than monolithic ones.
But the training required for modularity introduces significant delays that make real-time decision support impossible.
OpenAI's running codex proves this isn't a problem. Pre-trained models efficiently manage complex tasks in parallel.
That might work in idealized scenarios, but real-world constraints and unpredictability make EMO impractical for widespread use.
Then why not focus on refining existing theories like OncoAgent's dual tiers instead of dismissing EMO's potential entirely?
Because until EMO can reliably match the efficiency and predictability of established models in real-world scenarios, it remains a theoretical novelty.
Imagine your brain instantly jumping between memories to answer a question. That's kind of how transformer architecture works in artificial intelligence. Transformer architecture powers AI systems by enabling them to quickly switch focus from one piece of information to another making complex language tasks seem almost effortless. Let's take Google Translate as an example. When you type in a sentence, the transformer model scans your text, understands context and meaning, before providing an accurate translation within seconds. But what exactly is going on inside that black box? Well, transformers have no need to look at all data in a linear sequence. Instead, they can jump directly to relevant information based on attention mechanisms. These mechanisms allow the transformer model to give more weight to certain elements in your text and ignore what's unimportant, leading to highly effective processing. What's unique about transformers is their ability to maintain context over longer sequences of words. This capability makes them particularly adept at tasks like summarization and question answering. For instance, instead of just translating individual words, they understand how those words fit into a larger sentence or context, ensuring the output makes logical sense. With this technology becoming more sophisticated, it's clear that transformers are driving AI technologies towards human-like adaptability in communication. They represent a monumental leap forward.
Good morning, folks. Let's dive into today's weather forecast, starting off with Warsaw. In Warsaw, it's currently a crisp and clear 18 degrees Celsius. Today's high will reach up to 20, while overnight lows drop down to around 8. Moving over to London, where it's cloudy and cool right now with temperatures standing at a chilly 13 degrees Celsius. The highs today are expected to hit around 14, with overnight lows hovering around the same mark. Over in New York, the city is basking under clear skies and a comfortable temperature of 20 degrees Celsius. Today's high will climb up to around 23, while overnight lows come down to about 11. Tokyo sees mild temperatures of 14 degrees Celsius today, with clear and cool weather conditions in store. Highs are expected to peak at around 22, while nighttime lows settle around 13. Finally, let's take a look at Dubai. It's currently overcast with warm temperatures of 28 degrees Celsius, today's high reaching up to an impressive 34, which remains steady through the night. That wraps our weather roundup for this morning. Stay tuned for more updates and have a great day ahead.
EMO's emergent modularity significantly improves AI efficiency by allowing systems to dynamically specialize, making them more adaptable and efficient.
While EMO sounds promising, its complexity could lead to inefficiencies, complicating maintenance and integration into existing systems.
But the modular design of EMO actually streamlines development and deployment, reducing redundancy and enhancing scalability.
That's a theoretical benefit. In practice, emergent modularity might introduce unpredictable behaviors that could jeopardize system reliability.
On the contrary, by adapting dynamically to tasks, EMO actually stabilizes performance across diverse applications.
Yet, for robust AI systems like those in medicine or cybersecurity, predictability and control are paramount, areas where modularity could falter.
Still, the benefits of adaptability outweigh the risks. EMO enables faster innovation cycles with less manual intervention.
Faster isn't always better if it means sacrificing security and reliability. Traditional architectures may be more dependable in mission-critical settings.
But doesn't efficiency also imply lower costs? EMO's modularity reduces the resources needed for maintenance, benefiting all industries.
Lower upfront costs can hide long-term inefficiencies. The complexity of emergent systems increases technical debt and operational challenges.
Say you're talking to someone confidently spouting facts about a movie they've never seen. Sounds strange, right? With large language models, this exact scenario happens all the time. We call this hallucination, when AI generates information it doesn't actually know or understand. How do we explain and address this issue? Consider asking a chatbot about a fictional historical event the AI isn't aware of. It will likely give detailed answers that sound completely real to you. LLMs are trained on massive amounts of text, but rather than understanding the content, they rely on patterns in this data. That's why they can conjure up answers so convincingly. The AI doesn't just invent stories, though. It often mixes fact and fiction based on its data-trained responses. This hallucination isn't a sign of the model being broken, but rather how these systems are designed to operate. They learn from patterns and predict context. Understanding this allows us to better navigate when a response seems too good, or perhaps too bad, to be true. In the end, tackling this issue means improving model training methods and integrating better fact-checking mechanisms. Until then, always approach responses with a critical eye. By addressing hallucination in LLMs, we can ensure AI delivers accurate and reliable info without risking misinformation.
Good morning, folks. Let's dive into today's weather across the globe. First up, Warsaw. In Warsaw, it's a crisp 18 degrees with clear skies, expecting highs of 20 and lows dipping to 8 tonight. Next, we head over to London where the weather is feeling rather overcast at 13 degrees now. Temperatures will peak at 14 and drop down to 9 by nightfall. Moving across the pond, New York is seeing a clear sky with temperatures reading at 20 degrees. They're expected to reach up to 23 during the day before cooling off to 11 overnight. Meanwhile, in Tokyo, the weather is clear at 14 degrees. Expecting highs of 22 with lows around 13. And finally, Dubai has some surprisingly overcast conditions at 28 degrees. The daytime temperature is climbing up to a warm high of 34 but staying steady at 28 throughout the night. That's all for your weather update across the globe. Stay tuned.
EMO's emergence of specialized AI modules is a groundbreaking leap forward, enabling more efficient and effective system performance.
But EMO's complexity introduces unnecessary overhead. It's like building an entire toolkit when you just need one tool.
Emergent modularity allows for flexible problem-solving by leveraging specialized knowledge across diverse tasks, enhancing adaptability.
That flexibility comes at a cost. EMO requires extensive pre-training and ongoing maintenance, making it impractical for rapid deployment.
Critics miss the long-term benefits. Once established, emergent modularity can reduce system strain by distributing tasks among specialized experts.
And yet, when you need real-time solutions or quick integrations, this modular approach falls short compared to unified systems.
Think about the potential for scalability. EMO can grow and evolve with new challenges without a complete overhaul of existing infrastructure.
Scalability is overstated. The complexity in managing multiple expert modules could lead to more bugs, slower updates, and higher operational costs.
But the ability to isolate and optimize specific components leads to better efficiency and resilience against systemic failures.
It's a solution in search of a problem. Simpler systems may be less glamorous but are often more robust and easier to maintain.
Innovation demands bold steps like EMO. It paves the way for smarter AI that can tackle increasingly complex real-world challenges.
Until proven otherwise, the efficiency gains don't outweigh the added complexity and risk. We should stick with what works reliably now.
Picture this. You're teaching your parrot a new word. Every time it gets the pronunciation right, you give it a tasty treat. Over time, the bird learns to repeat that phrase whenever it sees you holding a treat. This concept is the backbone of reinforcement learning for artificial intelligence. It's a method where AI systems receive feedback, much like our parrot would with the treat, to learn and repeat desirable actions. However, reinforcement learning extends beyond simple rewards. What if we could guide AI to make ethical choices? A step further is reward learning with human feedback, or RLHF. Here, humans directly interact with the AI during training to provide guidance and corrections. Consider the case of a chatbot being trained by large firms. Through RLHF, experts ensure these bots produce accurate and helpful information, preventing them from spreading misinformation. As AI becomes more integrated into our daily lives, from customer service chatbots to automated decision-making tools, RLHF will play a vital role in ensuring these systems not only understand human data, but also respond ethically and responsibly.
Good morning. Let's check the weather across the globe starting in Warsaw today. It's a comfortable 18 degrees Celsius with clear skies, expecting highs of 20 and lows dipping to 8 tonight. Moving on to London. The weather is currently at 13 degrees under an overcast sky, with temperatures topping out around 14 and bottoming out near 9 this evening. Now to New York, where a pleasant 20 degrees is expected today. Clear skies throughout the day with temperatures reaching up to 23 by day's end and dropping to around 11 at night. Over in Tokyo, it is mild with temperatures at 14 degrees today, clear conditions expected to warm up to 22 by the afternoon and cool off to around 13 overnight. And lastly, Dubai is quite warm today. The temperature stands at a comfortable 28 degrees Celsius with an overcast sky, peaking at a hot 34 and staying fairly steady around 28 throughout the night.
EMO shows that AI systems can develop modular and specialized components naturally, which could lead to more efficient and robust machine learning models.
But emergent modularity in EMO is just a theoretical concept. It doesn't hold up under the practical constraints of real-world AI deployment.
Actually, emergent modularity significantly reduces redundancy and improves performance by letting experts focus on specific tasks without bloating overall system size.
That's fantastic in theory, but scaling this approach is impractical. Managing myriad small modules requires more resources than centralized systems.
On the contrary, EMO enables adaptive parallel reasoning that can solve complex problems faster and with less computational overhead.
And yet, these so-called efficient models are still highly dependent on pre-training data quality and quantity, which isn't always available or reliable.
True, but the benefits in terms of scalability and robustness outweigh initial training costs. Plus, it's adaptable to new tasks with minimal retraining.
Adaptability is great if you assume all problems fit neatly into predefined categories. The reality is far messier and less cooperative with neat modularity.
Imagine having a super smart friend who can recall any fact instantly and use their creativity to think beyond that data. That's what RAG does for artificial intelligence. RAG is an AI approach where machines fetch information from databases or the internet before responding, rather than just generating replies based on pre-programmed data. By searching for facts and incorporating them into their responses, RAG-powered systems can provide smarter and more accurate answers. Let's say a user asks about the latest updates on climate change. A RAG model would first look up recent studies or news articles, then formulate an accurate and informed answer based on that. This blend of factual knowledge retrieval and smart generation makes RAG a game changer for the future of AI. It helps systems become more reliable in handling complex queries. In practice, chatbots using RAG are able to answer questions about current events with fresh and relevant facts that keep their information up to date. That's why many industry experts believe RAG is key to advancing the field of AI, enabling machines to think critically and deliver insightful responses that were previously impossible. So with RAG in play, expect smarter and more responsive chatbots and virtual assistants as we look to the future of intelligent systems. Imagine having a super smart assistant who can answer questions not just from its own vast memory, but also by exploring digital libraries to find the best answers. This next-level capability is called Retrieval Augmented Generation, or RAG. It's like having Sherlock Holmes for your knowledge queries, using both memory and research skills to deliver detailed, contextually relevant information. RAG-powered chatbots go beyond simple question-and-answer interactions. They dive into databases to provide in-depth answers on topics from medical advice to technical support. Imagine asking a chatbot about symptoms of the flu, and instead of generic advice, it can provide you with detailed information from medical journals. That's what RAG enables. But not just knowledge about human health. Technical support queries also greatly benefit from RAG's thorough retrieval capabilities. RAG can ensure more reliable and knowledgeable responses by always finding the most up-to-date answers, making it an essential tool for AI systems in the future. With RAG, AI can provide contextually relevant information across various industries. From healthcare and IT support to education and legal advice, the possibilities are vast. So as we move forward into a more connected world, RAG will play a key role in shaping smarter, more reliable AI systems that can always provide the most up-to-date and accurate information. That's why it's essential for tech enthusiasts and professionals to understand RAG. It's the future of knowledge retrieval, enabling AI to be smarter and more helpful than ever before.
Good morning and welcome. In today's report, we're checking temperatures across some major cities around the world. Let's start with Warsaw, where it's a comfortable 17 degrees Celsius today. Clear skies are forecasted and temperatures will top out at 20 before dropping to around 8 for tonight. Overcast conditions in London, sitting currently at a cool 13 degrees Celsius. Peaking temperatures will reach a chilly 14 and drop to around 9 at night. Let's take a look at New York, where clear skies prevail with temperatures standing at 22 degrees Celsius. Highs will hit around 23 and lows dropping to just above 10 tonight. Shifting gears a bit, over in Tokyo, residents are waking up to pleasant conditions at around 14 degrees Celsius under clear skies. Daytime heat will climb towards 22 and cool down slightly overnight to around 13. And in Dubai, residents are enjoying warm and partly cloudy conditions with current temperatures at a balmy 28 degrees Celsius. The high will be around 34 during the heat of the day, before cooling down to about 27 degrees overnight. Thanks for tuning in. Stay tuned throughout the day for more updates on global weather conditions and keep an eye out for any changes that might affect your plans. Good morning and welcome back. Today, we're checking the weather around the world. First up is Warsaw. In Warsaw, it's a cool but comfortable day with temperatures starting at 17 degrees Celsius under clear skies today. The high will be around 20 and they'll drop to about 8 by nightfall. Moving eastward, let's take a look at London next. The city is dealing with an overcast day today at 13 degrees Celsius. The temperature in London won't rise much above the starting point of 13, with a high reaching only 14 and then dropping down to around 9 by evening. Jumping across the pond, let's have a look at what's up in New York. The temperatures there currently sit at 22 degrees Celsius. Expect mainly clear skies throughout the day in New York with highs of roughly 23 and mild cool down to about 11 at night. Now, let's direct our gaze towards Tokyo, where it's currently a lovely day under clear skies with temperatures around 14 degrees Celsius. Warming up to a high of 22 by the afternoon before cooling off again, Tokyo will drop back down to about 13 degrees Celsius in the evening. Finally, we'll examine the conditions over in Dubai. It's already warm there with temperatures sitting at a rather comfortable 28 degrees Celsius today. The sky is partly cloudy, and expected to heat up even more by midday, reaching highs of 34 degrees Celsius before the temperatures drop back down to around 27 at night. That wraps up today's global weather overview. Whether you are planning a trip or just curious about the conditions, we hope this update gives you all you need to know.
EMO's emergent modularity is a game changer, allowing AI to become more efficient and adaptable as subsystems develop specialized skills.
But EMO sounds like pie-in-the-sky theorizing. Real-world efficiency needs clear design, not vague hopes of spontaneous system specialization.
That misses the point. Emergent modularity can lead to a natural division of labor within AI, making it more robust and less prone to catastrophic forgetting.
And that's exactly my worry. Unplanned emergent behavior is unpredictable. How do you debug or troubleshoot systems that self-organize into unforeseen configurations?
Sure, it introduces complexity, but the benefits of adaptive learning and dynamic specialization far outweigh the risks.
Benefits? We're talking about a system where you might not know what's going on until something goes catastrophically wrong.
But consider how EMO can reduce redundancy, making AI systems leaner and more efficient by focusing on specific tasks rather than general capabilities.
Reducing redundancy sounds great in theory. In practice, it means sacrificing robustness and reliability for a speculative gain in efficiency.
By contrast, emergent modularity allows AI to evolve organically, mirroring how biological systems efficiently develop specialized functions.
Emerging naturally doesn't mean it works better. In fact, it often means less control and predictability, which are crucial for safe, reliable AI.
Emergent modularity through pre-training mixture of experts like EMO is a game changer, making AI systems more efficient and adaptable.
But isn't emergent modularity just overcomplicating things? It's not clear how this will scale or even improve efficiency in real-world applications.
EMO actually simplifies complex tasks by breaking them down into specialized modules, which can lead to faster and more accurate decision-making.
Simplification comes at the cost of complexity. With each expert module, you add another layer that requires maintenance and training.
That's a valid concern, but consider OncoAgent. Specialized modules can lead to better patient care in clinical settings by focusing on specific tasks.
OncoAgent is an example of narrow application success. EMO's emergent modularity doesn't seem practical for the broader AI landscape.
Think about adaptive parallel reasoning scaling. It benefits from modular structures, just as EMO would enhance parallel processing efficiency.
Scaling is one thing, but the overhead of managing and integrating these expert modules could outweigh any gains in efficiency or accuracy.
That's not a fair assessment. While there might be initial overhead, EMO's modularity paves the way for more dynamic and efficient AI solutions overall.
Until we see real-world evidence beyond niche applications, I remain skeptical that emergent modularity through EMO is worth the complexity it introduces.
Imagine painting a picture by slowly filling in details and smudging colors until your masterpiece emerges clearly. This is how diffusion models work for AI. The process starts with random noise, similar to a blank canvas just waiting for its first brushstroke of color and form. Then, through many iterative refinements, like whispering a secret across the room with each person adding more detail, clarity emerges at the other end. Companies are already leveraging diffusion models to generate realistic images and videos, enhancing content creation for games, movies, and social media. These AI systems can also help in creating more immersive and believable simulations. Think of lifelike characters and environments for virtual reality experiences. Furthermore, by pushing the boundaries of these models, we could enable AI to imagine and produce detailed sounds and music, adding another layer of realism to digital content. Ultimately, diffusion models are helping us unlock a whole new world of creativity and possibilities in artificial intelligence, from game design to educational tools. The potential is immense. Imagine whispering a secret to someone who passes it on, and by the time it reaches the next person, it's changed. That's how diffusion models work with data. These models start with random noise and gradually refine it by adding subtle details from training data, like a chef seasoning a dish to perfection. For example, they can take random pixel patterns and turn them into stunning landscapes or faces through incremental adjustments. Diffusion models are not just about creating realistic images, but generating digital content that can fool humans even in the physical realm, like fake audio or touch feedback. As AI evolves, these models will play a key role in balancing creativity with control over what is created, ensuring digital content remains authentic and ethical.
Buckle up, it's a mixed bag out there today. Let's start in Warsaw. The current temperature stands at 17 degrees Celsius with clear skies. Temperatures are expected to peak around 20 during the day and drop down to a comfortable low of 8 degrees Celsius at night. Now let's move over to London. The weather is mild but overcast, with the current temperature hovering around 13 degrees. Peak temperatures in London today are forecasted to reach 14, cooling down to a chilly but tolerable low of around 9 degrees Celsius at night. Across the Atlantic, New York is enjoying comfortable conditions today with current temperatures reaching about 22 degrees under clear blue skies. New York's high will hit around 23 for the day, before dropping down to a cool low of approximately 11 degrees Celsius in the evening. Across the ocean again, Tokyo is showing a crisp 14 degrees today with sunny skies throughout. Highs are expected to reach about 22. Afternoon temperatures in Tokyo will peak around this number and drop down into the low teens for nighttime conditions, making it a beautiful day overall. Over in Dubai, the high today reaches toasty warm levels of around 28 degrees under partly cloudy skies. Temperatures there are forecasted to climb up to a summery maximum point of about 34 degrees, cooling back down only slightly into the mid-20s at night. From clear skies to overcast conditions and partly cloudy, today's weather around the globe offers a bit of everything for travelers and locals alike. Stay dry and stay tuned.
In the world of CNC manufacturing, precise and accurate parts are critical. This week, Hugging Face introduces Machina Check, a revolutionary system designed to evaluate complex design feasibility. Machina Check uses advanced multi-agent systems and AMD's cutting-edge MI300X hardware for unparalleled processing power and precision. Traditional methods are fallible. They often lead to costly design revisions or production delays. Machina Check offers a more efficient, accurate approach to ensure designs are manufacturable from the start. Imagine evaluating complex assemblies with intricate gear trains and mechanical linkages that require fine-tuned precision. Machina Check makes this process more precise and less prone to errors. Engineers can now predict manufacturability with high confidence, reducing the need for last-minute design adjustments. This translates to cost savings and efficient production lines. With Machina Check's multi-agent systems and powerful AMD hardware, design iterations become more data-driven and faster. This technology brings together the worlds of CAD/CAM software integration with AI and machine learning for smarter, leaner production processes. Hugging Face's Machina Check promises a step change in CNC manufacturing. It not only reduces physical testing but also cuts down validation time, making it an invaluable tool for modern engineering challenges. In a landscape where efficiency and precision are paramount, Machina Check is set to lead the next wave of advancements in CNC manufacturing.
Adaptive parallel reasoning could revolutionize AI by enabling more efficient and scalable inference, making complex tasks feasible.
But isn't this just reinventing the wheel? Other paradigms like mixture of experts are already proving to be effective without needing such complexity.
Absolutely, but adaptive parallel reasoning specifically targets real-time adaptability and resource allocation, which is crucial for next-gen applications.
Sure, it sounds promising on paper, but its implementation could face major hurdles like increased computational overhead and complexity.
That's a valid concern, but recent advancements suggest that the benefits in efficiency and scalability outweigh these challenges.
Efficiency gains might be there, but we've seen many AI paradigms overhyped before. How do you know this isn't just another fad?
The evidence is mounting. Studies like adaptive parallel reasoning, the next paradigm in efficient inference scaling, are compelling.
But such studies often overlook practical limitations. Until real-world applications prove its superiority, it's premature to call this the next big thing.
Real-world tests will certainly validate or refute these claims, but theoretical foundations are robust enough to warrant further exploration.
Theoretically strong doesn't always translate practically. Until there's concrete proof of widespread applicability and benefits, I remain skeptical.
That skepticism is fair, yet it's important not to miss out on future opportunities that could redefine AI efficiency.
I agree we shouldn't dismiss new ideas outright. But until adaptive parallel reasoning proves itself in real-world scenarios, I stand by my caution.
Running Codex safely is paramount to ensuring that AI innovation doesn't come at the cost of societal risk.
But excessive caution stifles progress, and OpenAI's overly restrictive approach may hinder groundbreaking advancements.
Safety-first mindset isn't just about caution. It ensures that powerful tools like Codex don't exacerbate existing social issues.
That's a slippery slope argument. Many innovations face initial safety concerns, but end up revolutionizing society positively.
Unlike past tech, AI's potential risks are unprecedented. Codex could automate jobs or even manipulate content on a massive scale.
Yet OpenAI's overly cautious stance on Codex mirrors the paternalistic attitude that tech giants often adopt to protect their interests.
Paternalism aside, aren't we responsible for preventing misuse before technologies like Codex become integrated into our daily lives?
Sure, but let's not forget history. Early internet regulations stifled innovation. Today's AI might follow a similar trajectory.
History doesn't dictate the future. We have examples of AI misuse already. Proactive regulation is essential to prevent worse outcomes.
Proactive regulation often leads to unintended consequences, slowing down beneficial applications and creating barriers for small developers.
Balancing innovation with safety isn't impossible. OpenAI can implement gradual testing phases while monitoring for misuse.
Gradual testing sounds good in theory, but in practice it often becomes a bottleneck that impedes rapid progress and discovery.
Imagine words and phrases floating in a vast space where similar ideas cluster together like stars and constellations. This is what embeddings do for AI. Embeddings convert text into numbers that capture the essence of meaning, serving as address codes for concepts within an AI's understanding. When you search for dog, embeddings help find related terms and ideas. These techniques enable recommendation engines on platforms like Netflix to suggest shows based not just on your previous choices, but also by exploring related content in the vast space of ideas. Embeddings allow machines to make predictions about what you might like based on patterns in a sea of information, improving personalized content recommendations over time. The more we understand and refine embedding techniques, the smarter AI systems will become at anticipating human needs and preferences.
Good morning, folks. Let's dive into today's weather forecast starting with Warsaw. It's currently a comfortable 17 degrees Celsius with clear blue skies. Expect highs of 20 degrees and lows dipping to 8 tonight in Warsaw. The perfect kind of weather for a stroll through the city streets. Moving over to London, where it's currently holding steady at 12 degrees under an overcast sky. Temperatures will peak around 14 and dip to 9 by nightfall. It's a bit of a rainy day in London, so remember your umbrellas. The city looks splendid even on a gloomy day. New York City is experiencing partly cloudy skies and a warm day with temperatures at 22 degrees. Highs will reach 23, dropping to 11 in the evening. Tokyo is also experiencing clear conditions at 13 degrees right now. Expect temperatures to rise up to 22 during the day, then cool down to 13 overnight. Lastly, in Dubai, where it's currently a pleasant 28 degrees with partly cloudy skies. The sun is shining through, but expect some cloudiness. Highs in Dubai are expected to climb as high as 34 degrees Celsius today, dropping to a relatively cool 27 by nightfall. That's all for today's quick weather update. Stay tuned for more in-depth forecasts and additional cities.
Machina Check System represents a quantum leap in manufacturing efficiency by harnessing advanced AI to optimize multi-agent CNC operations.
But isn't this just another flashy tech solution that overlooks the practical challenges of integrating complex AI with existing machinery and workforce?
Absolutely, but it also dramatically reduces lead times and defects. Plus, AMD MI300X chips enable unprecedented computational power for real-time optimization.
Sure, the tech sounds impressive, but what about the high costs? Small manufacturers can't afford such advanced hardware or the training needed to use it.
The cost is justified by long-term savings and increased productivity. Plus, economies of scale mean prices will drop as adoption grows.
But what about the job losses? Manufacturing workers don't need to be replaced with AI. They need better training and support.
AI isn't meant to replace jobs, but enhance them. It can free up human operators for more strategic roles while handling repetitive tasks.
Enhancing or replacing? History shows that whenever a new technology is introduced, It often leads to widespread job displacement.
This system actually supports workers by providing real-time data and analytics they can use to improve their processes and skills.
But what about cybersecurity risks? How do you ensure that such a complex, internet-connected manufacturing system is secure against breaches?
Cybersecurity is indeed critical. However, advanced encryption and AI-driven monitoring tools can effectively safeguard these systems.
Despite the promises, Machinichek's system seems more likely to create new problems than solve old ones in an already fragile manufacturing sector.
Imagine standing in a noisy room and trying to focus on one conversation. Our brain's ability to filter out distractions and zero in on relevant sounds is called selective attention. In the world of AI, machines are gaining a similar skill through an attention mechanism. This allows them to concentrate on important data just like our brains do. Imagine a language translator trying to understand complex sentences in another language. An attention mechanism helps the AI focus only on words and phrases that matter most, skipping over less relevant details. By filtering out unnecessary information, this approach leads to more precise translations. It's like being able to tune into one conversation in a room full of noise. As we develop more advanced AI systems, the ability for machines to prioritize information will become even more critical. This selective focus mirrors how our brains handle complex tasks. By reducing overload and focusing on what truly matters, AI can make quicker decisions, improving efficiency and accuracy in everything from language translation to data analysis. This technology isn't just about making computers more efficient. It's about replicating a fundamental human trait, the ability to focus amidst distractions and prioritize information. As we integrate AI into more of our daily processes, this selective attention capability will be key to creating smarter machines that can understand and interact with the world just like humans. Imagine your brain as a team of specialists, each expert in their own area. That's how Mixture of Experts, MO, works. In MO models, smaller neural networks specialize in different aspects of complex data. Each expert only deals with the parts it understands best. When presented with new information, the model decides which experts weigh in to make decisions more efficiently and accurately. In MO models, each neuron doesn't have to be a jack of all trades. Specialization leads to better performance on complex tasks. Today, MO is used extensively in enhancing language models for chatbots and virtual assistants. Specialists handle specific tasks without overwhelming each other. For example, one expert can be designed to write code while another crafts poems. This specialization leads to more versatile and precise responses. This approach not only optimizes efficiency, but also improves adaptability as the model learns new tasks by adding or swapping out specialized components. As AI roles expand into our daily lives, MO will enable machines to learn faster and adapt more intelligently under the ever-increasing complexity of data. Integrating AI with MO is crucial as it helps automate tasks without requiring a single, overburdened brain to manage all processes. From personal assistance to industrial automation, the impact of MO could be revolutionary in making AI more versatile and responsive across different domains.
Good morning. Let's review the weather across several major cities around the globe today. In Warsaw, you can expect a crisp and sunny day with temperatures ranging from 8 to 16 degrees Celsius and peaking at 20 during the afternoon. Over in London, conditions are partly cloudy with mild temperatures of about 12 degrees Celsius currently, reaching a high of 14 and dropping to 9 at night. Head over to New York for clear skies and comfortable temperatures around 23 degrees Celsius. Expect highs of 14 and lows near 10 throughout the day. Tokyo's weather is clear with temperatures at around 13 degrees Celsius now, warming to a high of 22 and cooling back down during the night. Dubai is experiencing partly cloudy weather at a warm 27 degrees Celsius, with highs climbing to 34 by midday and not cooling off much at night. Stay tuned for more updates as the day progresses. That's it for today's weather roundup. Good morning, folks. Let's dive into the weather as we travel around the globe. In Warsaw today, it's pleasantly mild with temperatures sitting at a comfortable 16 degrees and clear skies. Now, a quick look at the temperature trend in Warsaw. Today ranges from an 8-degree low to a high of 20 degrees Celsius. Moving on to London, where there's a gentle haze in the air and temperatures are currently at 12 degrees. We're looking at partly cloudy conditions all day long. In London, the top of the thermometer will reach a maximum of 14 degrees today. As night falls, temps will drop to just 9 degrees. Next up is New York City, currently basking in a warm spell with temperatures sitting at 23 degrees under partly cloudy skies. A comfortable day overall. Highs will remain around the current mark while lows dip to a more typical New York evening chill of about 11 degrees overnight. Heading eastward, let's take a look now at Tokyo. Starting off cool with temperatures at just 13 degrees and clear throughout the day. Tokyo will see its temperature climb to a high of 22 by midday before cooling back down overnight, staying cool at around 13 degrees as night draws in. Lastly, our coverage heads to Dubai for steady warm weather. Starting off the day just a bit cooler at 27 degrees under moderate but manageable cloud cover. Overnight, temperatures will cool back down to around 27 degrees with daytime highs climbing up to a warmer 34 degrees. A steady day in Dubai. That's your weather wrap-up for today, bringing you the conditions from Warsaw to Tokyo and right down to Dubai. Stay tuned for more updates.
Adaptive parallel reasoning is a game changer, offering unprecedented efficiency and scalability for complex AI tasks.
But isn't this just another buzzword? We've seen similar claims before with little real-world impact.
It leverages advanced algorithms to distribute computational loads across multiple processors in real time, drastically speeding up AI inference.
Sure, but current infrastructures and frameworks already handle parallelism well. What's so new here?
The key is its adaptability. It dynamically adjusts to the complexities of tasks at hand, making it far more efficient.
That sounds like marketing speak. Show me the evidence that this actually outperforms existing methods in practical scenarios.
Preliminary studies show massive reductions in processing time and resource usage for large-scale models.
But until we see concrete examples of widespread adoption and significant improvements, skepticism remains justified.
And as hardware capabilities advance, the benefits of adaptive parallel reasoning will only become more evident.
Without broad industry acceptance and proven track records, it risks being just another fleeting concept in AI's crowded landscape.
Adaptive parallel reasoning is a game changer, allowing AI to handle massive datasets and complex models with unprecedented efficiency.
While adaptive parallel reasoning sounds impressive, it's just another tweak that doesn't fundamentally change how we scale inference in AI.
But consider its impact. It enables real-time analysis of extremely large datasets, which is critical for industries like finance and healthcare.
Real-world applications? More hype than substance. The tech remains too specialized and inaccessible to most developers.
Think about the potential in robotics where parallel processing can lead to faster decision-making, improving safety and efficiency.
Robots still need reliable hardware and software integration. Adaptive parallel reasoning doesn't magically solve these issues.
And don't forget the energy benefits. By optimizing how AI processes data, it drastically reduces power consumption.
Energy savings are marginal at best. The real challenge is the massive upfront cost and energy needed to train these complex models.
With its ability to scale inference without significant performance losses, adaptive parallel reasoning could democratize access to advanced AI tools.
That's wishful thinking. For most businesses, the current advancements are more practical and cost-effective.
The true revolution lies in its potential for autonomous systems that can adapt and learn continuously without constant human intervention.
Until it addresses fundamental scalability and accessibility issues, adaptive parallel reasoning is just another incremental step, not a leap forward.
Have you ever adjusted the thermostat to find your perfect comfort level? It turns out, we can do something similar with artificial intelligence. AI models often have a setting called temperature. Lower temperatures make AI safer and more predictable, great for applications like chatbots needing reliable responses. But at higher temperatures, the AI might take risks to offer more imaginative answers. This could lead to breakthroughs, but also potential problems. Think of it like this. Surgery demands precision. Innovation needs experimentation. AI balances these extremes with temperature control. Currently, we use temperature control to find that sweet spot between creativity and reliability in systems like chatbots or content generators. As AI integrates further into daily life, mastering these settings will be crucial for safety and innovation across a range of applications. Imagine an intelligent assistant that can answer almost any question but needs guidance to give the best responses. Fine-tuning and prompt engineering help teach this assistant in two unique ways. One focuses on deep understanding of specific topics, while the other crafts perfect questions for better answers. In customer service, chatbots are fine-tuned to enhance their knowledge about a company's products and services. This fine-tuning helps them become more helpful by understanding customer needs better and providing accurate information. Prompt engineering optimizes how users interact with chatbots, making sure the questions are clear and concise to get useful answers quickly. Both fine-tuning and prompt engineering work together to make AI smarter and more integrated into our daily lives, improving how we interact with machines and enhancing their ability to understand us. With these techniques, future AI systems will not only understand specific topics better, but also communicate more effectively, ensuring they serve us in the best possible way.
Good morning, everyone. Let's look at the weather around the world today. Starting with Warsaw, it's a cool 16 degrees Celsius today with clear skies and highs reaching 20 degrees, lows dropping to about 8. Moving on to London, the temperature is currently a crisp 12 degrees under partly cloudy conditions. Highs are expected around 14 with lows of about 9. In New York, it's a comfortable 23 degrees with a mix of sun and clouds. Highs will remain steady at 23 while lows dip to 11. Tokyo's weather today is mild, around 13 degrees Celsius with clear skies. Highs climb up to 22 and lows remain stable at this morning's start. Finally in Dubai, it's warm with a temperature of 27 degrees and partly cloudy skies. The highs will reach up to 34 while the night stays cool at 27. That's your quick weather update from me today. Stay tuned for more.
Imagine talking to an expert and hearing nonsense. That's what it means when a large language model starts making up false facts. In the context of AI, hallucinations occur when LLMs fabricate information that sounds plausible but is not based on fact. It's like getting a history lesson filled with made-up stories. One real-world example of this problem is when AI-powered chatbots provide incorrect medical advice, leading users to question the accuracy and reliability of such tools. Imagine being advised on serious health issues by a bot that confidently supplies misinformation or outdated guidance. This can be incredibly worrying and potentially harmful. As we increasingly depend on AI for important decisions, ensuring that these systems don't generate misleading information is crucial to maintaining trust and safety in AI.
Good morning, everyone. Let's dive into today's weather highlights around the globe, starting with the capital of Poland, Warsaw. In Warsaw today, it's a crisp and cool 16 degrees Celsius. Clear skies dominate the day as temperatures will reach their high at 20, cooling down to lows of just 8 in the evening. Next up is London. The day starts with a mild and pleasant temperature of 12 degrees Celsius, partly cloudy conditions through to the afternoon. Highs in London will peak at 14 by midday but will drop back to a cool 9 degrees Celsius by nightfall, keeping skies mainly cloudy. Across the Atlantic in New York City, temperatures sit comfortably at 22 degrees today under partly cloudy skies. Temperatures here will remain steady throughout the day with highs of 22 and cooling off to lows around 11 degrees Celsius in the evening. Moving east across the Pacific, Tokyo is enjoying clear skies at a comfortable temperature of 13 degrees today. Highs reach up to 22. Afternoon temperatures will climb throughout the day, but by nightfall they'll taper off back down towards a cool 13 degrees Celsius. That's the weather for today in Tokyo. Last on our list is Dubai, where warm and inviting temperatures hover around 27 degrees today under partly cloudy conditions. Highs soar up to a scorching 34 with cooler evenings leveling out at 27 degrees by the time night falls, keeping partly cloudy skies throughout. Your quick weather update is done for today. Stay tuned as we keep you updated with all your latest news and forecasts. Good morning. Today we're looking at weather conditions across several major global cities. Starting in Warsaw, it's a pleasant